69 factorial. Okay, 69 factorial is approximately 9.8 times 10 to the power of 98 or something like that. I mean, this is the last one, okay? 70 factorial would have broken it.
Error.
So are we convinced that 100 factorial is a pretty big number? Okay? Just because your program can work with a smaller number does not mean it will work. It will scale up, in a nice way. Okay? So your boss decided to fire you because your program embarrassed him in front of his friend and the company. And then you say, boss, you can fire me, but I guarantee that no one that you can hire will solve this problem, any faster than I could. Now, that's a big statement, isn't it? You're telling your boss that, if he fired you and hired the next person cannot do any better. Okay? So how can you do something like that? Well, fortunately for you, this type of search and optimization problem is what we call NP-complete. Okay, NP-complete is a term, you can look it up on Wikipedia. It's basically saying that this problem is transformable into a well-known standard problem that is known to be difficult to solve. Okay? In other words, we have an entire class of problems that are quote-unquote equivalent in terms of difficulty. And all of these problems, they may look very different, but in the end, each one can be transformed to the next one using a small amount of time. And this problem, as it turns out, to be one of those problems. It's one of the more classical examples of what we call intractable problems. In other words, in the brief history of computer science, about 50-something years, no one has ever tackled these problems and be able to solve it in a quick fashion. So what are the chances that your boss can hire the next person to be able to solve this problem efficiently? It's almost none. Okay? So that's how you can keep your job, is to convince your boss that this problem is NP-complete, and as a result, there's no chance, or the chances is so slim it's not even worth considering. Because if the next person can solve this problem, that person is not going to, is not going to write the program for a pizza delivery place. That person is going to go get some sort of medal, in an international, community and get rich and famous and not work for the pizza shop anyway, right? And we have just about 5 minutes left. The next question is, why do we call this NP-complete? What does the NP actually stand for? It doesn't stand for not possible. Okay? The N stands for non-deterministic, and the P stands for polynomial. Okay? So this means, with a non-deterministic machine, it will only take polynomial time. Polynomial time means it is big O of n to some constant power. So the question is, what exactly are we talking about when we talk about non-deterministic? In today's term, we can think of it as infinite number of cores. Okay? It is, n means you have an unlimited number of cores, and you can, when you run out of threads, and processes, guess what? You just say, oh, I just need one more core, and magically another core appears, and you can perform, whatever you want to do in parallel with everything else that you're doing. Okay? This is basically saying that with a magical computer that has an infinite number of cores that can operate in parallel at the same time, it will still take polynomial time, something like this, to solve the problem. Okay? That's what NP-complete stands for, or what the NP part represents. So you have now some exposure of concepts they won't talk about until the last class of a 4-year university. But at least you know the context. You know why it is important to know this stuff and approximately what it represents. Okay? And we are running out of time, so we'll see. I'll meet you guys on Thursday. If you come in late, don't forget to sign the roll sheet. I'm, kind of reverting back to paper.
The first time you've done that since?
Yep.
I've been late a couple of times.
Sorry?
I've been late a couple of times, so have I missed that?
No, this is the first time I took road.